of benzene. What he is doing? He is practicing the structure of benzene. If you keep on doing the same thing again and again, it creates impressions in your mind and things are stored in the form of images in your brain. After a lot of practice, now it's going to be difficult for you to forget it instead of remembering. I don't think any one of you have to remember how to draw A because you have practiced it a lot. In medicinal chemistry also you have to do a lot of practice to remember the structures, synthesis and structure activity relationships. It also doesn't matter whether you belong to which class of IQ qualification. Even if you belong to low IQ classes, you can perform very good in the examination like superior or very superior candidates. Only the difference will be in the practice. You may have to do more practice, you have to put a lot of efforts to achieve the things like superior or very superior candidates. But after a lot of practice, the positive thing is that you can do it. So always say, I can do it. If you go through the syllabus of Medicinal Chemistry 1 as per PCI, you will find it very big or vast syllabus. But you can make the things easy like the Henry Ford. And I quote here, nothing is particularly hard if you divide it into small jobs. Let's take one example. Suppose you are asked to build this beautiful house. Initially, you may find it difficult to construct house like this, but you need to have a plan. Then you have to find out what are the basic things required, then how to do it. So what are the basic things required to construct the beautiful house? It may include bricks, cement, sand, water, stones, glasses, iron, etc. The things required for the construction of any house. So you have to start with the smaller things to achieve the big. So let's make the syllabus of Medicinal Chemistry 1 easy first. Unit 1, Physico-chemical properties in relation to biological action and drug metabolism. Then Unit 2 is drugs acting on adrenergic system. Unit 3 is drugs acting on cholinergic system. Unit 4 is divided into 3 topics: sedatives, hypnotics, antipsychotics, and anticonvulsants. And finally, Unit 5 is general anesthetics, narcotic analgesics and antagonists, and anti-inflammatory agents. Now it looks easy to study the medicinal chemistry 1. Syllabus looks vast only because the number of drugs included are more. And the important thing is, same topics are also included in your pharmacology subject, which makes it more easy to learn medicinal chemistry in the same semester. So in this way, medicinal chemistry syllabus is also very easy to learn. Before starting the medicinal chemistry subject, you need to answer two questions. Number one is, what to learn in medicinal chemistry 1? Then second one is, how to learn medicinal chemistry 1? Let's answer the first question, what to learn in medicinal chemistry 1? Unit 1 is physico-chemical properties in relation to biological action and drug metabolism. We will study this part in upcoming videos. Here we are going to focus only on the rest of the units, that is Unit 2, 3, 4 and 5. How to learn Unit 2, 3, 4, 5. In Unit 2, 3, 4 and 5, you have to learn things like chemical classification of drugs, mechanism of action of drugs, structure and IUPAC names. Around 162 drugs are included in your syllabus. That's why syllabus looks vast or big. I have already made videos on all the units with the structure and IUPAC names. So links are given in the description. Please go and watch those videos also. Then you have to learn the synthesis of around 22 drugs specified in your syllabus, along with two biosyntheses like acetylcholine and catecholamines. From catecholamines, you may be asked to write the synthesis of dopamine, adrenaline, or noradrenaline. And finally, the most important part is the structure-activity relationship of 9 drug classes. So, one by one, we'll see how to study all these things. Chemical classification of drugs, mechanism of action of drugs, structure-activity relationship, structure and IUPAC names, all these things. Okay, friends? Now, let's answer the second question, how to learn medicinal chemistry 1. Let's start with the classification. Drugs can be classified on various bases like onset of action, where drugs can be classified as slow acting or fast acting. Then second is on the basis of duration of action like ultra short acting, intermediate acting or long acting. You must have seen this classification in the barbiturates. Then third is on the basis of mechanism of action. Here, drugs are classified on the basis of their mechanism of action, how they shows the pharmacological activity. Then fourth one is chemical structure on the basis of chemical structure. In medicinal chemistry, this classification is important. In exams, you may have questions like this, classify drugs on the basis of chemical structure and draw one structure from each class. So let's take one example. This is the chemical classification of anticonvulsant drugs, about which we have already discussed during the anticonvulsant drugs. So please go and watch that video also. Friends, once you practice the drug structures, you can identify their heterocyclic nucleus or what are the important nucleus present in the drug structures. And then on the basis of their nucleus present, you can classify them on the basis of chemical structure. Then second thing you have to learn in medicinal chemistry 1 is the mechanism of action of drugs. How they produce their pharmacological activity, that you have to explain here, which will be same in pharmacology and medicinal chemistry. as you have the same syllabus in the pharmacology and medicinal chemistry 1, it's very easy to learn all the mechanism of actions. But when you look at the number of drugs, that is 162 drugs in the medicinal chemistry 1, it makes you scared how to remember mechanism of action of all these drugs. But it's a very simple thing. You just have to make a format of answer, then just replace the names of drugs belonging to the same class and acting on the same target. Let's take one example. The drugs belonging to barbiturate class, it may be 8 or 10 drugs. All these drugs acts on the same site, barbiturate site, present on the GABA-A benzodiazepine chloride channel complex and produces the pharmacological activity. So in this way, all these drugs produces the same mechanism of action. In the same way, the drugs belonging to the benzodiazepine class like nitrazepam, diazepam, oxazepam, alprazolam, chlordiazepam, all the drugs binds with the benzodiazepine receptor present on the GABA-A benzodiazepine chloride channel complex and produces the pharmacological activity. So, like this, you can remember the mechanism of action of many drugs. But while writing the mechanism of action, you need to have some knowledge of this thing. Drug binds with the target available, which can be receptor, enzyme, ion channel, etc., and forms the drug receptor complex, which then gives the pharmacological activity. So, while writing the mechanism of action of any drug, you must know the target first, and then what happens after the complex formation that you have to explain during the mechanism of action of any drug. If you go through the unit 2, 3, 4 and 5, only around 10 to 15 targets are there where all these drugs binds and produces their pharmacological activity. So even if the number of drug structures are more, the mechanism of actions are very few. Let's see what are the different targets involved in all the units. In unit 2, we have to learn drugs acting on the adrenergic system, and the receptors involved are adrenergic receptors like alpha 1, alpha 2, beta 1 and beta 2 receptors. So here you have to learn about these receptors and then you can write the mechanism of action of adrenergic agonists and antagonists. Then in unit 3, you have to learn the drugs acting on the cholinergic system. So here you have to learn about the receptors like nicotinic receptors and muscarinic receptors. And the indirectly acting cholinergic drugs acts on the cholinesterase enzyme, where these drugs inhibit the cholinesterase enzyme for the metabolism of acetylcholine. Then in unit 4, sedatives hypnotics have the primary action on GABA-A benzodiazepine chloride channel complex, where barbiturates and benzodiazepines produce this action. Then in the antipsychotics, the drugs have the primary activity on the dopamine receptor. Then in the case of anticonvulsant drugs, the drugs have mainly actions on the sodium and calcium ion channels, and then the important target is GABA-A benzodiazepine chloride channel. Finally, in unit 5, the general anesthetic drugs, they also have the primary action on the GABA-A benzodiazepine chloride channel. Then the narcotic analgesics and antagonists have the action on the opioid receptors, while the anti-inflammatory drugs produce their action by inhibiting the mainly enzyme cyclooxygenase. So these are the only targets available in your syllabus where these drugs can bind and produce their pharmacological activity. So read about them in details, which will make it very easy to write the mechanism of action of all these drugs. Then the third important thing you have to learn in the medicinal chemistry 1 is the structure and IUPAC names of drugs. I have already made videos on this topic, how to give the IUPAC names to all the 162 drugs, so please go and watch those videos also. Here, we will see how to avoid the mistakes while drawing the drug structures. First, you need to know the valency of elements which are more commonly found in the drug structures, so that you can show the proper number of bonds required for each element. So the most commonly found elements in the drug structures are like hydrogen, carbon, nitrogen, oxygen, halogens like fluorine, chlorine, bromine and iodine, and then sulfur. So valency is given in the last column, like hydrogen forms 1 bond, carbon forms 4, nitrogen 3, oxygen 2, and halogens like chlorine, fluorine, bromine, iodine forms 1 bond, and sulfur, depending upon the oxidation state, forms the 2, 4 or 6 bonds in the drug structures. Here, I have shown the most common valencies of these elements. They can form more or less bonds also, like carbon can form 2 bonds in carbene, chlorine can form 7 bonds in perchloric acid. So, if nitrogen and oxygen forms 1 more bond, like nitrogen forms suppose 4 bonds and oxygen forms 3 bonds, then you have to show the positive charge on the elements, like nitrogen and oxygen. So while drawing the structures, make sure you have completed the valency of all the elements, so you can avoid the mistakes while drawing the drug structures. Then, after valency, you should have a knowledge about the different functional groups in organic chemistry, like alkanes, alkenes, alkynes, alkyl halides, alkyl amines, nitriles, alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, amides, carbamic acids, different functional groups in the organic chemistry. It will help you to remember the drug structures. It also helps you while writing the IUPAC names, and also it is helpful during the writing the structure activity relationship. So you should have a knowledge about the different functional groups. Here I am not going to explain about the different functional groups. You already learned. If you want to learn about this, link is given in the description. Please go and watch that video also. After the knowledge of valency of elements and functional groups, you must know the ring structures like benzene, naphthalene, anthracene, phenanthrene, and heterocyclic rings. What are heterocyclic rings? The ring which contains element other than carbon is known as heterocyclic ring. I have extracted these heterocyclic rings from all the drugs of your syllabus. Around 31 different heterocyclic rings are there. So, in upcoming videos, I will provide you the tips for remembering the structures on the basis of all these heterocyclic rings. As the video is getting longer, here I will explain you how to remember drugs based on one heterocyclic ring. I think all of you know the structure of imidazole. If you reduce one double bond, then imidazole becomes imidazoline. And if you reduce both the double bonds, then it becomes imidazolidine. In Unit 2, 6 drugs acting on alpha-adrenergic receptors have this imidazoline nucleus. So let's see what are the structures of those drugs. First, you have to draw the general structure of drugs based on the imidazoline nucleus like this, where X is the linkage which can be CH2 or NH. NH linkage is found in the clonidine and other molecules have the CH2 linkage. Then R is the substituent which is mostly aryl ring. Let's draw the structure of tolazoline. Tolazoline acts as a non-selective alpha-adrenergic antagonist. Now, let's see how to remember the structure of tolazoline. In general structure, if you replace X with CH2 and R with phenyl ring, then it becomes the tolazoline. But important hint is in the name of the drug itself. Do you know the structure of toluene? This is the structure of toluene, benzene ring with one CH3 group. In the structure of tolazoline, this part is from the toluene, therefore name starts with the tol, T-O-L, and azolene is for the imidazoline. So, wherever it is possible, try to get the information from the name of the drug itself. It helps you to remember the drug structure easily. Many times you get that information from the name, but if it's not available, then you have to use other hints about which we are going to discuss in upcoming videos. Let's take next example, that is phentolamine. It is also non-selective alpha-adrenergic antagonist. Do you get any information from the drug name about its structure? Here, phen is for this phenol, then tol is for toluene, and amine is for this nitrogen amino group. So, in general structure, you have to replace X with CH2 and R with substituted amine, that is phenol toluene amine. Another important thing you have to remember in the position of phenol and toluene. Phenol is attached to nitrogen at meta position, while toluene is attached at the para position. In this way, you can remember the structure of phentolamine. It's not possible to cover all the drugs in one video. So, in upcoming videos, I will provide you the hints to remember the drug structures unit by unit. Then, next important thing you have to learn in the medicinal chemistry 1 is the synthesis of specified drugs. 22 drugs are there along with 2 biosynthetic pathways. I have already made videos on biosynthesis of acetylcholine and catecholamines. Please watch those videos also. About these 22 drugs, you will get videos within 2 days from now. While writing the synthetic pathway, you need not to explain mechanism of reaction, that is, how reaction proceeds. But you must know what changes are occurring during the reaction. That helps you to remember the pathway. If you want to know how I teach the synthesis, you can watch my video on the phenytoin, where I have explained the synthesis of phenytoin. Then the last important thing you have to learn in the medicinal chemistry 1 is the structure-activity relationship of 9 drug classes. It is the most important thing that you have to learn in the medicinal chemistry. I have already made videos on some of the classes, you can go through them. Structure-activity relationship is the relationship between structural changes and its effect on the activity of drug. Let's take one example here. While writing structure-activity relationship, first thing you have to do is to draw the general structure or structure of prototype drug. Then divide it into these important parts like shown here. This is the structure-activity relationship of sympathomimetic drug. If you want to watch the full video, please go through the video. Link is